In this video, we'll produce the player mechanics behind our arcade game. We will create the horizontal movement and the attacking ability for our player. To set up our player, let's create a sprite game object. Sprite game objects contain a sprite renderer component used to display images in two-dimensional games. To create the sprite game object, right-click in the hierarchy panel. Navigate to 2D object and select sprite. Rename this game object player and reset the transform of the game object. Navigate to the sprite renderer component in the inspector panel. Add the player image by clicking on the bullseye icon for the sprite variable and select player ship. Next, let's create our enemy game object by right-clicking in the hierarchy panel, navigating to 2D object again, and selecting sprite. Name this game object enemy. Reset the transform of the game object, and let's add the enemy ship sprite. Now we're ready to get our player moving in our game. Create a new script by right-clicking in the project panel, navigate to create, and select C# script. Name the script player. Then select the player game object in the hierarchy panel and add the player script from the project panel to the list of components in the inspector. Unity has a few great built-in tools like the input get access function for helping us map user input. Imagine a two-dimensional plane with the horizontal and vertical axis. In the middle of the two-dimensional plane is a red circle. This red circle symbolizes the user's focus, changing depending on the input given. As the player holds down the down key on the keypad, the focus would move negatively on the vertical axis. The getAccess function returns the location of the red circle for developers like us to map the movement of the player's game object. Since the player in our game is only moving side to side, we only have to worry about the horizontal axis. We will get the input from the user in our update function, which is called every frame of our game. To hold the location of our user focus, let's create a new float inside our update function called horizontal. Next, let's set the horizontal float equal to the user focus on the horizontal axis using the input getAccess function. Now let's apply the user input to the player's game object by accessing the transform of the player using the translate function. Multiply the horizontal float by time.delta_time. This will allow our player to move smoothly regardless of the current frame rate of our system. Next, let's create the projectile. Right-click in the hierarchy panel, navigate to 2D object and select sprite. Reset the transform and add an image. There's a variety of ways to shoot this projectile. We'll be moving our projectile by accessing the velocity variable on the rigid body 2D component that we'll be attaching to our projectile. I like using this method because it allows us to apply normal physical constraints like gravity to our projectile. And though we aren't using gravity in this game, I still choose to use this method because I think it'll apply to the broader audience. Select the projectile and click the Add Component button in the Inspector panel. Add a rigid body 2D component. On this component, we also want to make sure that we freeze the rotation on the Z-axis and we set the gravity scale to 0. Now let's create the script for our projectile. Right-click in the project panel, navigate to create, and select C# script. Double-click the script to open it in Visual Studio. First, let's create a private rigid body 2D component and set it equal to the rigid body component on this game object using the getComponent function in the start method. To move this projectile towards the enemy, let's use the velocity variable on the rigid body 2D component, setting it equal to vector3.up. We can also increase the speed at which the bullet flies by multiplying vector3.up by 10. It's also a good idea to destroy the game object after we're done using it. Otherwise, our game will suffer from lag after so many game objects are spawned into our scene. So here I'll destroy it after 5 seconds. Now let's test our code. All that's left to do now is to shoot our projectile every time the user clicks a specified button. To fire a projectile, we'll need to create the location for our projectile to spawn to. Let's right-click on the player object and add a new empty game object named gun barrel. Reposition the gun barrel to the end of the spaceship's cannon on our player, and then open the player script again in Visual Studio. To instantiate a new projectile, we first need to create a public game object for our projectile prefab. We will also need the location of our gun barrel, so create a public transform variable for that as well. To fire the projectile, let's add a new if statement to the update function. This statement will listen to input from the user and fire a projectile when the input is given. Similarly to the getAccess function, we can use the getButtonDown function with the parameter fire1 to listen for input. Unity has mapped this keyword fire1 to the left mouse button in the space bar. Now call the instantiate function inside the if statement with the projectile prefab, along with the location and rotation of the gun barrel. Now let's return to Unity. Make the projectile prefab by selecting it in the hierarchy panel and dragging it into the project panel. Now we can delete the projectile from the hierarchy. Now select the player and add the gun barrel transform and projectile prefab to the new variables on the player script component. Now let's test our code and make sure that we can shoot and move side to side without any problems. In the next video, we'll be adding enemy effects to our game, including movement, explosions, and more. Subscribe to make sure that you don't miss out on any of our new videos. And if you have any questions, feel free to leave them in the comments below. Thanks for watching.